Hello, welcome. This is the session Designing Azure Data Science and AI Projects. I'm going to be your presenter, Neil Hambly. Let's have a quick look at what we have in store for this session. Let's explore what PARS has to offer before we get really started into the session. There's the Pro Membership. That's brand new, just recently come out. Have a look at that. It's got some exclusive training and networking capabilities there for you. You're going to have your local PARS chapters. Check out where your local one is. Mine's in London, and I've helped run that for several years. There's going to be the SQL Saturdays. These are the one-day events that mostly on Saturday, sometimes a Friday. I've seen them as well. They're going to be in your local area. Find out where these are on SQLSaturday.com and go and explore, kind of joining one of those. You won't regret that. PARS Marathon is the online virtual back-to-back sessions. I've been involved in a few of those, and they usually focus around a certain topic or technology at that time. We've also got the virtual groups. Now, this is going to be very, very relevant right now because of kind of the travel issues that we have. So check out what the virtual groups are. There's many of them, and you can subscribe to those and find out when they're doing online events. And finally, are you a PARS volunteer? If not, would you like to get involved? Check out how getting involved as well. Speak to your local chapter, and there's other resources on pars.org. You can go and check out about being a PARS member. So before we start the session, we're going to remind you about the evaluations. You would have heard this a few times throughout the conference. It's very important you do give us your feedback. I especially want to hear about it, so please do let me know, what you liked and didn't like maybe about the session, how I can improve it, what other questions you might have, and generally about the PARS event itself. So you'll see the session evaluation link in the left-hand side of your navigation, and go and rate this session. Please do so. I look forward to seeing what those are. Who is Neil Hambly? Why am I here? Why am I presented? Well, I presented at PARS a few times already over the years. Really enjoyed doing those sessions. Been in some of those very large rooms before. They are a little bit overwhelming when you're on that stage and you have several hundred people in some of the groups I've been into. So really good. But unfortunately this year it's all virtual. So hopefully this format's going to come over okay. If you have questions, we're going to open the chat window towards the end of the session. So you can kind of put your questions in there. And I will be doing a live Q&A with you guys at the end of the session. Otherwise, if you want to get in touch with me, here's my LinkedIn, Facebook, and Twitter details. I've been working with SQL Server and kind of database technologies for over 20 years. I kind of been even doing community events for over 10 years. I've done, I think, over something like 400 presentations right now. My current role means I'm a Microsoft certified trainer, which means I do a lot of training right now for folks on a virtual basis, so virtual student classes, and I really enjoy doing those. Okay, let's get started with the Designing Azure Data Science and AI project, because that's why we're here. Now, this is one of the half-day sessions. That means there's 2 hours of content and then Q&A. A bit longer than some of the regular kind of 60-minute sessions you would see throughout the conference. I enjoy doing these half-day ones. It gives me a bit more time to share more knowledge and kind of interact with the audience. That's a little different this year in terms of the interaction, but I'm sure we'll have a good time doing it. Let's go see what we have in store. Okay, this is the agenda. Well, this is part of it. There's going to be another screen in a second. We're going to first kick off with looking at the session objectives. Why are we doing this session? What was the objectives of the session? What we're going to share? What knowledge are we going to kind of go through here? So we're going to start off with one of the methodologies called CRISP.DI. I'm going to explore that in a lot more detail for you shortly. Then we're going to move on to a more recent kind of methodology that I tend to use for my projects called the team data science process. This is the one that Microsoft use themselves, and this is where I'm going to be sharing a lot of the demos and other information from that process. We're going to talk about Azure Machine Learning Service. This is the service that Microsoft offer, kind of doing the machine learning technologies. Got a whole bunch of stuff in there to share with you, so we'll go through in a lot of detail around that. There's a specific product called the Data Science VM, which is a VM with pre-built algorithms and programs pre-installed. It's an image essentially with a lot of the data science tooling you'll need. So we're going to explore that and show you how that can be really useful for team data science process and even individual projects. But we're not finished. We do have a second page of agenda. It is a 2-hour session after all. We've got the data science tools. These are the tools that you'll use inside of your projects. We're going to look at Visual Studio Code. There's also something called Visual Studio Online and just Visual Studio itself. They're pretty much the engine underneath it, all the same. We've got some extensions, we've got some ways of working with all these technologies. I specifically like the Visual Studio Code product, and it's free. We have Jupyter notebooks and Python scripts, so we're going to show how these fit into your data science projects and where you can make use of these in a number of tools like the Jupyter Lab, Jupyter itself, Data Science VM, Azure Machine Learning Service. We've got a number of places we can run them. Anyway, you can run a notebook, essentially, you'll be able to leverage those technologies. There's a couple of others. There's the Azure Data Studio. Really love this new tool, again, free, really useful for data science projects and be able to connect to all the different resources. But I like the approach so we can actually run like Jupyter notebooks in there as well, and a whole bunch of other project-based kind of capabilities that we didn't really have before. And data is a dominant part of any data science project. So we're going to look at Azure Storage Explorer, a way to connect to and work with our data inside of those storage accounts. We will have something called machine learning ops, or ML ops. We'll show you a demo, walk through some GitHub repositories and take you through from start to finish on how to kind of operationalize your machine learning projects. That's going to be a really useful one. And then we're going to do some additional tips around delivering projects. And we'll round out the session with that Q&A. So you've got questions, we'll put them into the chat window, which gets opened up towards the latter half of the end of the 2-hour sessions, about an hour and a half in, we'll open that up. And then you can put your questions in, and then we'll do the Q&A from those questions. Okay, so before we go into all of the learnings and all the kind of tutorials and all the stuff we're trying to share, let's be clear about what we're trying to do in this session. So what were the session objectives for this? Well, the first one was, we know that data science projects are pretty much a lot more common than they used to be. You know, go back 10 years, there were projects, but they weren't as common as they might be today. So if you were DBA, you probably didn't get involved in data science projects. And you know, where do you start? So that's what we're going to do. We're going to kind of do a start to finish workshop. We're going to have some demos that take you from starting that project, building all the relevant assets you need, building the team, finding the project, and then kind of, you know, building out those pipelines and processing those models and deploying them. So here we have the learning objectives that we're trying to do in this main session. We're going to look at the team data science process. We'll have a quick look at CRISP.DM before, but we're going to focus our attention on the team data science process and the 5 life cycle stages we have there. We will outline each stage, and we will show you kind of more details about what each stage is about. We're going to focus in on some specific areas. We're going to focus in on the data. You know, where is it? How do we wrangle the data? What's the new term for that? Kind of what is the preparation? What's the feature engineering? How do we prepare it? These are the things we're trying to achieve. And then we're going to look at model feature engineering. How do we build models? How do we work out the accuracy? How do we evaluate them? And then once we're ready, how do we deploy them? This is the main focus. On the right there, you'll see a nice little canny photograph of me. Got taken at one of the conferences, I think it was in the UK. And a bunch of badges for the exams and certifications that I teach and also hold. So we are going to kick off with CRISP.DM. It's an acronym. It means Cross-Industry Standard Process for Data Mining. So you can see where the CRISP.DM comes from. And what is it? Why are we interested in this? Why is it important? Well, let's go and figure that out. But it's a methodology, and like all methodologies, we have kind of stages, and we can see here comparison versus the older CRISP.DM methodology and the newer team data science one, the one that we're going to be focused on. The only real difference is we do some data exploration in team data science that we probably wouldn't have done previously in the CRISP.DM. But essentially, they're the same stages. Understand, what's the business questions we're trying to answer here? Why are we trying to answer those specific questions? We want to know that. We want to put down on paper what questions we're trying to answer and why we need an answer and what importance there is to that answer. Once you understand why we're doing something, it can shape how we achieve that. So we're going to need some data to make this all happen. After all, it's the data science. So we're going to grab some data, we're going to acquire it, figure out what data we need, what's the resources, where they are, how do we get that into a central place to do our analysis and preparation. So that kind of initial understanding and acquiring that data, that's going to be really important. The data doesn't come in nice and clean and tidy. It's not prepackaged for you, unless you're the lucky person that sits on the other end and they get that clean data. And if so, let me know how you achieve that. But we're going to cleanse some data, and actually the first kind of 3 stages, or acquire and clean data at least, will be about 60 or 70% of all of your time in a data science project. Doing that legwork, doing that kind of investigation, analysis, cleansing the data, getting it ready, feature engineering it. That's the stuff that data engineers and the data scientists will do. And you're probably going to involve people like the business analysts or the data analysts and the business itself to kind of figure out what it is you need to do. Once we've figured out and we've explored the data and we understand it a bit better, maybe some visualization, that's going to be kind of where we need to then start. How do we model this? How do we build our models? What algorithms are we going to use? Why do we need to go with one type of algorithm like regression or clustering versus another? What's the purpose of the questions we're trying to answer? We'll drive that, and we're going to look at some assets that we can kind of show you that help with those decisions. How do we work out what parameters to use? How much data do we need? How do we split the train and test data sets? Once we've kind of figured all that out, which is kind of difficult sometimes, and you're probably going to go for an iterative process to get to the right stage of that, we need to finally evaluate the model, figure out if it's meeting the requirements of what we're trying to achieve, and if it is, how do we compare it maybe with some other models, and what is the best model? What's the best parameters to use? So we might use some hyperparameterization and some AutoML capabilities to figure that out. And then we're going to look at deploying this. And where's it going to go? Is it going to go in a container? Is it going to go in a Kubernetes service? So we're going to explore that, show you where we kind of figure out what the best deployment plans, how do we wrap this around a DevOps with machine learning ops? All these kind of questions we're going to try and answer in this session as best we can. Let's see how we get on. So first we're going to just set the stage a little bit with the understanding what CRISP.DM is. Again, the cross-industry standard process for data mining. And it came in 6 phases. And basically it was a life cycle. We started with the business understanding. What questions? That's what we're trying to figure out. We don't have that defined well enough. Keep going until you do, because the rest of the sections that follow are going to depend on how well you do that first section. Now we're going to look at data. We need to figure out where it is, what type of data, how much we need, is it clean, now what quality is it? All those questions need to be figured out, and we need to process this data in some way, probably taking it from a raw, unclean state to our engineered, ready to go to put it into a data mining model. So how do we do that? That's what the data preparation is all about. How do we organize that stages? Who gets involved? How do we know when we've got to the right stage of that? So what tools and technologies can we use to make that data preparation effective and repeatable? So we're going to look at how we automate some of that as well. We will be looking at modeling in some ways. We're going to go through, we need to get all this data ready to put it into the model, to then train the model based on the way we've defined the model. We want to train it, run some test data through it, validate it, get it ready so we can kind of say, okay, this is going to be what we're going to deploy. Let's get it out there and let's kind of get our users running it. So we're going to involve our stakeholders throughout the whole process. If you leave it to the very last minute kind of to bring them in, I'm pretty sure your project's not going to be successful. They need to be part of the business understanding. They need to have some input into the various phases. When I'm doing data preparation, what kind of things should I be looking out for? What is good data? What's bad data? Let's get their view on that. What techniques should I use? Now, maybe they don't have understanding about machine learning technologies and the algorithms. That's fine. But we need to understand from them what is their key criteria, what is their kind of expected outcome from it. And that might help us drive what decisions we make in terms of the algorithms we're going to use. Evaluation is all about making sure the model that we've chosen is fit for purpose. That's pretty much it. Does this model achieve the objectives? If it does, let's get it out there. And if so, how do we do that? And how do we put pipelines and kind of gating operations in place to make sure this all does what it needs to do? And we can kind of put it out in the real world and get people using it. And then get feedback, get monitoring on the system. Maybe come back and retrain the model at some point. So this is what the main system is. We're going to go through and just kind of pick this apart a little bit, just so we kind of get the understanding well on these different phases. Let's do that. So let's start with business understanding. We're going to focus on the key objectives and requirements of the project. We have 4 kind of tasks here we need to do. We need to determine the business objective, and that's a thorough understanding of what it is we're trying to accomplish. Let's write it down. Let's work out what the success criteria needs to be. Makes it kind of seem obvious and straightforward. Of course we do that. Yeah, that's fine. The amount of times I've seen projects like, we're struggling trying to get this piece and this piece working. It's like, great. What is it we're trying to achieve? And everyone's got a different idea because there's no written kind of strategy. It hasn't been confirmed with everybody what the end goal is. We don't know what success criteria is. So we're all working in different directions. We're not got a single direction to work in. We don't know what the end goal is. I guarantee you there's a lot of projects out there that's happening exactly like that. So determine your business objective, make sure everyone understands what that is, and it's aligned to the customer's expectations. Now we need to figure out what resources we have in hand. Do we need to build some assets like machine learning workspaces? Do we need to build some VMs? Where's the data? Where's our Azure data lake store? We're going to use one of those. Where's our storage? Where's the data actually coming in? How much data do we need? Do we 1 year's worth of data? 10 years? No. So we need to figure out all of these resources. That's going to include things like time constraints, financial resources. Do we need to go and do a cost and benefit analysis? Bigger projects might kind of need to figure out what we spend our time on and how much money we're spending. And is it worth us doing this thing for the outcome we're going to get the benefit of that? We do need to find what we call data mining goals. Now, this is essentially a bit more of a technical aspect. It's like, how much detail do I need this thing to provide? Is it kind of just a prediction, yes or no? Is it a more detailed explanation of the data and prediction? So what's the technical requirements we're trying to achieve out of this? So we need to figure out what that is. And finally, we need to put some project stuff around this stuff. This thing doesn't, you just go, guys, you know what the business objectives would go? That kind of doesn't work. You need to kind of plan your project, have timelines, deadlines, checkpoints. We need to kind of understand what we're doing. Are we doing something like a sprint? We're doing 2-week sprints, whatever it is need to be, what kind of project management. So there needs to be some tool and technology and people probably process in play to make this really successful. So the business understanding is understanding what we're trying to do, what assets and resources we need, what's the success criteria, and how we're going to go and do this. Okay, makes sense? Cool. This piece, I think, sometimes doesn't get enough of a look in. Data understanding. What I mean by this is, oh yeah, we've got some data in the database over there. Let's go grab some details, kind of do some quick data analysis. We're good. What data do we need to achieve the outcome? How are we going to document, the quality level of it when it came in? What processing have we done against that? How do we explore that data? There's lots of steps we can do to make this data better. We might do a principal component analysis on the data to understand the data better. We want to verify the data quality. What steps do we do to clean it? Do we kind of just remove nulls? How do we deal with lots of different ways of improving the data quality? And there's different techniques and capabilities inside of these tools to make that happen. So we need to figure out what our strategies might be around that. But ultimately, it's about getting the data, looking at the data, analyzing it, make sure it's right for what we need, maybe do some feature engineering on it if it needs to happen to improve the kind of depth and detail about the data. Query it, visualize it, understand it better so people know what data we have, where it came from, document it, and then just kind of say, we're ready to go. We've done these checks. It has passed these tests. We are now ready to go on and do that. Or we've validated that we do have data issues, but for now we're going to accept those and move forward. Just document those and move on. So you might have data quality issues that can't be addressed right now because in the source system, and we can't really do any changes to that because it's going to affect the outcome. It depends on the questions you're trying to ask. How cleansed the data becomes might be a factor as well. Okay, so think about these. That is the data understanding phase. Here we're now going to move on to data preparation. So what's that different to data understanding? Well, this is the kind of finalization. This is moving it into maybe tabular data sets and kind of using pandas maybe to create data frames. We're going to work out what data we're going to use. We're going to remove any data we don't want to include, so maybe outliers and that kind of stuff. We will kind of maybe have a process to go through and kind of capitalize data or whatever it might be to remove spelling errors and these kind of things. But we need to figure out what those cleanse data steps are. Remember, garbage in, lots of garbage out. We put garbage data in, why are you doing the project in the first place? So it's got to have a quality level. Let's kind of figure out some things that might need calculations. So an example might be the body mass index, the BMI. So we're taking people's heights and weights and we're doing a BMI calculation because we may be doing medical research or some kind of analysis. Very commonly, data science is often used in those fields and we kind of want to know what the BMI is. Maybe we've got an example where we're looking at diabetes later on. We want to know what the BMI value because that's maybe relevant to the data set. We're probably going to maybe have multiple data sets at some point, and we're going to want to work a way how to kind of put that together. How does it join? How do we integrate? So we're going to figure out if there's some integration of data, some maybe adding data at the bottom each time. We've got new records coming in on a daily basis. How do we append that data? How do we merge the data from multiple columns? And formatting, important. Is currency in US, English, European? What is it? What's this currency? What's the formatting of the data? So mind yourself to how you store the data, what data types you're using, what values you're going to use. And also numerical values may be changed to categorical values at some point because of the algorithms and the data science what you're using. So figure out if I need to do maths on this, how do I kind of represent the data and how do I do a final preparation stage to get it into the right stage? Do I need to have just 2 decimal points? Or am I going to maybe have like 8 decimal points or 9 decimal points or 4? What is the number I need? Am I doing currency conversions? All these kind of things may play into your data preparation stage. This is what people think of when they think about data science is the modeling. Okay, which algorithms am I going to use? Is it neural net? Is it regression? Is it deep neural net? What is it I'm doing here? Is it clustering? It's going to depend on the questions you're trying to ask, what type of algorithm you're going to use. And then inside of those categories, clustering, regression, etc., which specific algorithm is the best one for us? We may want to go and test a bunch of them to figure that out. Generate your test design. Now, what we mean here is, when we look at it, is we need a training data set, testing data set. We're going to need to validate the data with some additional data. We're going to have to work out how this can be used in the real world. So when you're thinking about the data, thinking about how you split the data into these different test and training data sets, etc. You're going to need to do some coding at some point, or a little bit of UI, which kind of translates into coding at the end. But we need to kind of understand how we build these models. What's the model workflow? We get some data, we perform some operations on that data, we'll pass it through a number of machine learning algorithms, we'll get the scoring of that, we'll get the evaluation. What's this all about? How do we compare that? So we're going to kind of build that model. We're going to build the steps to actually create a model at the end of that process. And then we need to assess that against maybe different parameters, different algorithms, and work out which one then meets the criteria best for the project. You could have some that are very similar, but you might go with one because it's a slightly better kind of a learning rate on that algorithm. So lots of knowledge, lots of decisions to make. The domain knowledge is going to be very critical from the end users and people that know the kind of field that you're working with a lot to understand the best decisions. It's not just a technical decision. It might be down to the way that you want that model to kind of operate. We'll make decision on the best algorithm to use. And how does that change over time? And how do you get feedback on the use of that system? And lots of things we need to do. But initially, right now, we're going to figure out how to build that model, create a model at the other end, and then deploy that. So we're going to look at the evaluation phase. And that's going back to question one. What's the business understanding? What's the business question? So we need to say, here's the model. Let's get a question, and let's put that question to the model and see how well it performs. If we get a kind of accuracy and outcome that we're happy with, we've done the project well. I suspect that won't happen the first time round. Usually you might have to go through at least a couple of rounds, iterations of this in order to get to the end goal. How do we figure out if we've done everything? We've not overlooked anything, were all the steps completed? Well, we need data about the process. So we're going to look at any summarization, any findings, any kind of steps that we've done, any things in the preparation phase that we decided to do that might have affected the outcome, any adjustments in the algorithms, the parameters we're using. We need to understand what those are. But based on all of those being done correctly and the evaluation being successful, and we understand what the model does and we're happy with the results, then we have a final stage to do, which is the deployment phase. Now, this is when we start saying, hey, customer, we have a new model for you to test out. And we can give them an access to that model and they can try it with their data. And they can maybe do some feedback. We might go and tweak a few things or even go back to the drawing board even and go back and start again. But we need to have these. We need to have a deployment plan. How are we going to put this model into operation? Once it's there, how do I do the monitoring and maintenance of this? So how do I kind of change anything that might need to change over time? How do I gather metrics to understand how well it's been used? How many times it's been used? All these bits of information. We might want to create a final report that we kind of present. It kind of says, right, it's been in operation for a week now. These are the findings. These are what we're seeing. How well does that stack up against our expectations? And we may want to do a project review as well, which is kind of looking at how well we did the project. What were the challenges, obstacles we encountered? You know, how do we get things better in the future? Like normal projects, you go through, you do a project review and go, well, now that was a problem. We stuck at doing that. Let's kind of figure out a way to make that less of a problem next time around. So that's the 6 phases. It's kind of taking you through business understanding, acquiring the data. We're then going to kind of do the preparation on that data. We're doing modeling phase. We're doing our evaluation. And then finally, we got our deployment. So we've got all the 6 phases out there ready to go. Okay. That's the CRISP.DI. That's kind of the foundation of data science, been for many, many years. But now we're going to explore kind of the more recent, I think it was like 2015, 2016, it came out as a kind of methodology, and it was built predominantly on the CRISP.DI. Actually, yeah, 2016. This is more of an agile, iterative data science methodology that kind of was using more of the Microsoft technologies of the day and kind of just a bit more of a modern approach to doing it. Now with this, we've got 4 major components of that. We've got our data science lifecycle, which we're going to go and explore in a bit of detail. We have a project that kind of aligns to that. So how do we create a standardized project structure to use the team data science process? What kind of resources and infrastructure can we use for that? Is there templates? Do we have DevOps and MLOps and GitHub and all these resources there? And what other tools and technologies and utilities can we leverage to make this kind of work for us? Okay, so that's what we're going to spend some time doing, is going through all of that. Okay, so let's move on to the TDSP lifecycle. This is where we document the different phases that the team data science process has. So we start with business understanding, work our way through data acquisition and understanding, the modeling phase, then on to deployment, and finally customer acceptance. But here we also see that we're adding in the project roles. So which individuals fall into which roles. So are you a solution architect or project manager? Maybe you're part of the data team, that's the data engineer and data scientist and data analyst. And the application developer and project team leads are also going to be part of that delivery for deploying and managing that project overall. We start with the business understanding, and we're going to obviously document what are specific questions we're trying to ask and what's the focus of the project itself. Same as we had with CRISP.DI, we're building on that initial methodology. We're going to do data acquisition and understanding. This is where we need to figure out what our data sources are, what pipelines we're going to need to build, what environments we're going to use, so what VMs or other requirements in terms of maybe Python libraries we might need. And then we're going to need to look at the data itself, clean it up and prepare that. So that's what the data understanding acquisition is all about. We obviously go and move on to the modeling phase, which is going to have some feature engineering. We're going to need to train that model and make sure that we're using the right algorithms and what parameters we're going to use in, and lots of other kind of model management aspects there. And then we're finally doing the evaluation, figuring out which is the best model that we need, what type of characteristics we're going to use for that model, what parameters, and how we're going to deploy that. So we've got lots of testing as well to do around that model evaluation phase. Eventually, once we've maybe done a few iterations of these phases, we're going to end up where we can move on to deployment. And that's getting then the scoring and the performance characteristics added to that and deploy it out into maybe an Azure container instance, an ACI, or Azure Kubernetes service. So we're going to maybe have a lot of containers that are going to then be managed. Finally, we're going to need to get that into the customer's world and have them accept that, validate, make sure it's exactly what they need, and then we can kind of move on. So this is the phases that we're going to go through. We're going to explore this in a little bit more detail right now. So here we're seeing a breakdown of the different phases along the top and the different roles down the side, and we're showing kind of what the different tasks and artifacts, the ones in green are artifacts and kind of outcomes, and the tasks are in blue here. So we're going to start off with the business understanding, and we've got the project leads and the project manager are going to kind of set up the stage of how we're going to approach the project, what are the requirements of the project itself, the charter that we need to build. And then we're going to move into the data ingest and understanding. So we're going to then figure out how we store the data, where it's going to come from, what are the assets that we need in terms of compute and machine learning and workspaces and all of that. We're going to maybe have a document that comes out of that that explains about the data and the requirements of that. We're also going to, further down, have the solution architect kind of step in as well, and they're going to design the overall solution architect and create some diagrams and understand how all the plumbing works together. On the modeling phase, we have our feature engineering, which is all about kind of getting the data into the right shape, so we can actually maybe extract and do more information with that data, enhance it some way that it's ready for the model development phase. And we'll have a report that we're going to build around what the model is, its characteristics, what algorithms, all those lovely bits of information we need to have available to us. We start building those pipelines to get us to the point where we can actually get that data in, process it, and move it through. So we're going to start building the infrastructure for this as well. We will have the deployment phase, which is going to include the scoring, as well as additional information about monitoring and health and other information. Again, we're going to document that and maybe have some dashboards available for us to look at inside of the machine in the workspace or some other reporting capabilities. And there are some out there we can kind of use, Grafana, some others, to understand what the use of those systems are. We will have a deployment pipeline being built as well. So how do we get from development to deployment? and how do we move these models into those production environments. And finally, we're going to have an acceptance sign off from the customer. So there's quite a bit of information here we need to also document around transitioning the support tiers, how we document what the activity levels are of this, what does the functionality is, what's all the different requirements that we need to probably build over the time of the model development. So we finally get a project kind of final report about how the project's gone, maybe success criteria, SLAs, that kind of information will also be encapsulated in that document. Okay, let's look at the project side of this. So we're going to need to do some project planning. That's the kind of how long it's going to take to do different tasks, which teams are involved, which groups are going to be doing it in which order, maybe which sprints they're going to be included in if you're doing maybe like a 2-week sprint. And then the individual tasks are going to also be managed. There's a number of different tools out there that you can kind of leverage to do this. And it's really down to the individual company as to how they approach this. But the tasks, the process is going to be fairly similar in each way. We're going to have different tasks. We're going to kind of work out how we deploy those into each of the sprints, who's going to sign off on those, how we commit code changes, how we put that data into different kind of stages of coming from raw to pre-processed to prepared, cleansed, and then finally kind of going into the model. And what's the output, results, reports, all this information would need to be put together as well. And then finally, we're going to have like a sign off on those steps, reviewed, approved, and then obviously, we're going to do some project management of the source control itself. So this is one area that kind of will probably be the success or failure of your project, is how you manage the project, not just the technical elements, but that's how we progress through and do all this. So a very important thing to undertake. Okay, let's have a look at what we did, very similar to the CRISP.DM. We're going to quickly go through. Here we can see what goals each of these phases are going to look at, and then how we go about doing that. So first off, the goals for business understanding is about understanding what metrics are the success of the criteria for the project itself. So how do we know when we've got the end goal that we're looking for? What is the questions we're trying to ask? What will be success criteria? So how do we do that? So we're going to define the objectives, and we're going to identify the data sources. So this is where we kind of work with our stakeholders to define what is it we're trying to do, what questions we're trying to ask, and then how we go about achieving those. And then what data sources will be important for us to work with in order to make this all happen. So that's going to be the business understanding phase. As part of that business understanding phase, we need to define those objectives. We need to kind of say, here's the tasks that we're trying to do. And we've broken this down into 4 sections just to give us more clarity on that. We need to understand what the central objective is. What's the key business variable that this analysis is going to achieve for us? Maybe we're doing forecasting of probability of sales. Maybe we're trying to figure out whether that the kind of order we're processing or the transaction is fraudulent in nature. So we're trying to process all that information to figure out an outcome, a prediction. We're also going to define the project goals by kind of just making it a bit more succinct in terms of what we're trying to do here. So it's very unambiguous. We've got things like 5 types of questions. How much or how many? That's requiring a kind of regression type approach. Which category? That will be a classification. Which group is a clustering type? Is this weird? Anomaly detection, and what options should be taken is a recommendation. So we need to figure out where we fit into these types of questions. Generally, you might only be one. Sometimes it might be, I'm trying to answer 2 questions at the same time. So you really need to be very specific about what you're trying to do and probably get it into just one category. If you're trying to kind of go into multiple categories or groups, then you're not clear enough, and that's going to spread across multiple algorithms, and then you're going to not really kind of probably have success. We also want to understand who's doing what type of role. What's the objectives and responsibilities of that team member or that group? So if you're the data scientist, what's your role in this project? If you're the data engineer or the project manager, you're going to have different responsibilities there. So figure out who's going to be doing what, create a high level milestone to do that. And then we can kind of understand if you've got the right resources aligned, and maybe you might need to add additional resources to make the project successful. And finally, we want to be smart in how we define our success criteria. So we want it to be specific, measurable, achievable, relevant, and time bound. If we can put it into those categories, then we can measure it and we're probably going to be successful. And the other item we had here was identify data sources. So we need to figure out, is it relevant? Do we have the right data? Where does it come from? And ultimately, if we don't have the right data, we're not probably going to be able to get the right answer. Remember, garbage in, garbage out. So we need to make sure we're doing it really carefully in terms of evaluating the data, doing that introspection of the data itself, figuring out, do we have the right relationships in this data? Where did it come from? Is it up to date and current? How much data do we need? Do we just need 1 month's worth of data, 10 years worth of data? What is the amount of data? Especially if we're going to have maybe predictions, we need enough relevant data in order to make enough data points to predict. Now, 1,000 rows is probably not going to cut it. But maybe you don't need 200 billion rows to achieve your end goal in terms of your model. And does the data need to be current enough? Is there trends in that data that significantly change that would actually change the outcome? So the amount of data and what data we're processing on and training on will actually determine the outcome prediction of that. So look at new sources, look at how you can update your systems, make sure it's currently correct for the processing. And maybe you're going to find that when you process last month's data, you get a certain outcome. You process last year's data, you get a complete different outcome. And maybe a different algorithm might be needed to do longer term analysis. So what are we going to create as an output from the business understanding? Well, we're going to have a charter document which is going to define all of those business requirements. And we're going to have this as a live document. It's going to be changing over time. Not the project in terms of, it's scope change, we're going to add things, change. But we need to make sure that we're documenting everything. So as we go through different phases, we're adding in the detail. That's what we mean by a live document, changing, not the question change. Data sources and the things like data dictionaries, we need to work out what data we have, how it relates, what are the different sources, where they are. So we're going to document all that information, as well as maybe scripts on how we go and achieve those and how we bring that pipelines in together. Let's move on to the second phase, which is the data acquisition understanding. So again, got a couple of goals here. The first one is to create a high quality data set where relationships to the variables we need are fully understood and known. We need to work out how we put those data sets into maybe our analytics workspaces and environments. Is it ready, prepared, cleansed, ready for our data modeling? So we're going to have an architecture design that kind of shows where the data is coming from, where we're going to store it in the different phases. Maybe we've got a complete raw directory, then we're going to a kind of prepared directory, an error handling area, and finally kind of a cleansed data set that we're going to use then to ingest into our model. So we've got 3 tasks we're going to do. We've got the ingest the data, we've got explore the data, and we've got set up new pipelines. So we're going to look at those in more detail now, but we need to figure out how we get the data in, how we analyze the data, explore it, understand it better, and then how we build these pipelines to repeat that process. So let's take the first of those, ingest the data. This is probably going to be one of the biggest parts of the project, is getting the data into your system and then also being able to process that data in certain ways. So where's the data held? Is it in blob storage? Is it a SQL database? Is it from some data warehouse structure? Is it other database information systems? Is it a CRM? So we're going to bring all that in, and we may have some staging. We may bring data into something like an Azure Data Lake store and then process from there. So lots of options for us to do that. In terms of kind of like how we then navigate and process and handle the data inside of those systems, depends on what system we're talking about here. So we've got databases, we've got storage accounts, we've got things like the Azure Machine Learning Services, we've got Synapse Analytics. It's going to vary on what technology you're using as to how you kind of stage and process that data. I think this is one of my favorite areas, is explore the data. As a data scientist, a data engineer, you're going to want to have an interest in what the data is telling you. Data itself probably comes in incomplete, noisy, inconsistent. It's uncleansed. It needs to be processed. It's going to have errors maybe in it. It's going to have duplicates. It's going to have missing values. How we deal with those is the essence of getting that data from an unclean to a cleansed state. That's going to be the challenge. And this is where maybe 50-60% of your time as maybe a data engineer or data scientist is going to be spent figuring out how to do that. Because ultimately, if you get the data quality to the right level, then you put that into your training model and your testing, and then you're going to get the right results or accurate results out of that model. If you don't do this well, you're going to have poor quality going in, and you're going to have poor quality coming out. So some of the tasks that we're going to look at are data cleansing, the transformation, potentially reduction. So, do we have just a sample data set required? What is the attributes inside of that? Do we need to change some of these from numerical to categorical? How do we use that with certain machine learning methods? And any text cleansing. So we do need to remove spaces, do things in terms of the record breaks, the line breaks, etc. Do we have to cleanse the data with capitalization, just lowercase in all of it, or uppercase in, whatever it might be, to cleanse the data to the right state that we need? And potentially you're going to kind of replace spelling errors and that kind of stuff as well, cleanse it up. Often people kind of, especially, they do a lot of spelling errors. And if you try to group things in categories and the spellings kind of errors are still there, you're going to maybe have more categories than you need because it's spread across multiple different spellings of the same thing. And then we're going to look at how we need to build the pipelines. So depending on the technology, you might be using Azure Data Factory, ADF. You might be doing something inside the Azure Machine Learning Workspace. You might be doing stuff inside of the SQL databases. There's additional Azure pipelines as well. There's lots of options for us to build those pipelines and workflows. So it depends on how you're going to do it, how often the data changes. Are you doing kind of store procedures? Are you doing things inside of the kind of maybe Synapse Analytics workspace itself in terms of kind of getting data processed in? You name it, there's going to be probably as many different approaches as there's probably different data sets out there. So you can choose how you approach it. I would standardize as best you can and have just kind of a couple of different approaches to doing that data. And it depends on what the data is. Is it batch-based? Are you doing streaming or real-time data? Or is it a combination of both of those? So it depends on what the data and the kind of cadence of that data in terms of how often the data changes, how much new data is coming in, how does that affect the model that we're going to be using? Are we kind of trying to predict outcomes? We probably need more recent data, and we may need to do real-time analysis to really kind of make that accurate enough. Let's say you're a clothing store, you've got an online website, and people are kind of selecting different, piece of clothing. You may want to do a recommendation system, but you want to do it really up to date in terms of what people are choosing in the last, say, maybe a couple of hours worth of activity. So you may be constantly kind of pushing that data through into your model in order to get those recommendations as close to the current trends as possible. And of course, we have some outcomes of this phase as well. We have deliverables in terms of a data quality report showing what the data was, when it came in, what relationships we have, how we've cleansed and improved that, what types of data sets we have. Lots of information about that, and there's some tools available for us in that. We have the architect document, which will outline how the pipelines are running in terms of how kind of different technology phases are implemented. And then we'll have some checkpoints in terms of kind of working out when we need to maybe go back and do another iteration of that kind of delivery. So did we get to the success criteria enough to move on to the next phase? So figure out, do we need to get more data? Have we got the accuracy in the model enough to a high level that we can actually go on to the deployment phase? Let's move on to modeling now, and we're going to look at the goals inside of this modeling phase. What are the optimum data features that we need for this model? Do we have them? Have we achieved that? What does this machine learning model predict? Is it the most accurate way of achieving the target that we're trying to do from the questions we're trying to ask here? So can we achieve that result? And is it going to be suitable for production? So we have to ask these questions, and we need to figure out how we achieve that by looking at the tasks involved. That's the feature engineering, so getting the data features correct, the right level, apply that to the raw data and getting our outcome. Model training is about getting the right accuracy or best we can and making sure that it's at the right success criteria in order to move forward. So we've had a question, success criteria. Now, how do we make sure that we're achieving that? And then finally, it's just, is this model going to be suitable for production? So that's a question that we need to figure out, do we have the right pipelines? How do we deploy that? What happens with changes to the model? How do we incorporate those? So we're going to also decide on what type of deployment. Is it an ACI? Is it Kubernetes? Is it going to be a combination of those? Is it a web service output? So for those who really not come across feature engineering before, essentially it's about taking that raw data that we have and making more distinct information coming out of that. So do we have, for example, a date and time value, and we want to work out what hour of the day this data occurred? We want to put a bucket, is it morning or afternoon? It was 9 a.m., 10 a.m., 11 a.m. What is the breakdown of it? So we're going to need to understand the features of each of the columns. So each column is going to be a feature, and then we're going to work out how it relates to the overall model itself, and what are the key features that are going to drive the accuracy of the model. So we're going to do some analysis and understanding of that. This is where the domain expertise comes into play. It's like understanding how the data really should look, how it works for this specific type of data set, what kind of scoring we need to put in place to figure out if the data has changed significantly in one way or the other. So lots of options around figuring out how to deploy that, how to get that in place. So feature engineering is going to be just figuring out how data relates to itself. Is there relationships between one data set and another data set? And how does data itself have internal relationships, internal features that we need to expose and understand? So when we go about figuring out how to train our model, we need to ask ourselves a couple of questions. First off, probably is which algorithm we're going to use. Now, we may not know, so we may need to kind of have a few iterations of figuring out what is maybe a good one, and narrow that down as we go through a few iterations. But ultimately, we have some ways of helping us kind of figuring that out. So we have some cheat sheets essentially that kind of say, well, what type of question are we trying to ask here? And then how much time do we want to spend training the model? What's the complexity? We want to figure out what those are. So we're going to look at some examples of figuring that out. But also, we may need to train a few different models and then can do the comparison. So something like AutoML, automatic machine learning inside of the Azure machine learning service can help us with that. What we're going to do with the data. So we're going to bring that data in and we're going to apply that to the model in terms of splitting it between training the data and then testing it. So maybe something like a 70% or 80% split for training and a 20-30% split for testing that. We're going to figure out how we get the accuracy of the model to the best level, what parameters we might want to use. So there's going to be some requirements that we need to figure out, which is maybe the accuracy of the model, the training time that we need to play with. What's the linearity of the model if we have them? What parameters or number of parameters are being fed into this model, and what number of features? Based on that, we can probably determine what is the best algorithm, or narrow the field at least down to a couple. We can then test those out and figure out how the data works in each of those, and then what the accuracy of that model is. So to help us with that algorithm choice, we have a cheat sheet, the machine learning cheat sheet from Microsoft, that helps us kind of ask a few simple questions that kind of break down the category at least to where we're going to fit into. And then in there, we can make some further decisions. So first off, we're going to choose from one of the algorithm types: classification, recommendation systems, clustering, anomaly detection, regression, or text analytics. So does it fit into one of these? And that depends on the types of questions we're trying to do. So are we trying to predict between two categories or multiple categories? Are we trying to predict the value and outcome? Are we trying to do anomaly detection and figure out what's unusual there? So once we've kind of broken this down a little bit, we can then decide at least the grouping of algorithms we're going to work with, and then decide inside of that how we're going to choose the specific algorithm or narrow the field a little bit. Okay, now we're going to look at the model training, and we're going to focus in on the accuracy. Now, this is how effective the model is in terms of predicting the true cases against the total cases that we're trying to process. So the higher we get the accuracy, the better, of course. In Machine Learning Designer, we have the Evaluate Model module, which will have some standard evaluation metrics that we can make use of in order to establish the characteristics of that model, the training data, and the performance of it. We will have 3 different ways to score the Evaluate model. We can generate scores over the training data and order to evaluate the model, so kind of push the training data through and see how well it performed. We can then also generate scores on the model, but compare those to a reserved set of testing data. So we want to figure out, here's our specific set of test data, and how well does the model perform against that? We probably spent some time kind of making sure that that's a good, accurate kind of set of data that we can know the output from. We're also going to potentially looking at 2 different models and pushing the same data through it and then relating to see how well one model performed against the other. So we're going to compare those scores and make a decision about which of those models will be the most appropriate one to go with. Another element would be the training type. Now, some of these models, when you train them, can take considerable amount of time. Some are faster, some are slower. It depends on the specific number of algorithms, the size of the data set itself, and the parameters you're defining. So now we're going to look at training type. Now, in supervised learning, training means using the historical data to build that model and reduce the amount of errors as close as we can to 0. That may take minutes or hours to train that model to get the accuracy. Depends on the specific algorithm and kind of the accuracy we're trying to achieve. And also some algorithms work faster than others. The number of hyperparameters, the number of kind of limitations we want to put on the amount of training time. So the more training time generally probably equates to probably a more accurate model than by reducing that training time. But we can define the amount of time that we want the training model to happen. One of the reasons for that is it can be expensive to run very long training times. So we want to kind of be pragmatic in terms of when do we kind of reduce the amount of training time to get a more cost-effective model, but at a reasonable price. So, just think about, how much time, maybe a couple of hours might be a suitable kind of limit on most training, but it depends on the data, depends on the algorithm really at the end of the day. So we're going to have a 3-step process. We're going to choose a particular algorithm that we want to do, and we're going to define the various parameters or hyperparameters for it. We're going to provide a data set and label that data set and make sure that it's a fully compatible data set for that algorithm. And then we're going to connect that to the train model module. We're going to show you some examples of this in the machine learning service in a demo upcoming. Once we perform the training, we will then look at that and perform a scoring module over that to get us the information about how well the module performed. And so the amount of time it's going to take to run the training side of this, the module that does the training, that's going to be dependent again on the amount of data, the module, and parameters and other information. But you can sometimes make a distinction or say, I don't want to run this over, say, a 2-hour period. But we can go and see that. Sometimes they're only a few minutes, depends on the data sets. So now we're going to look at the linearity potentially in the statistics, the machine learning, to see if there's a linear relationship between the data you have, the variable, and a constant in your data set. So we're trying to predict a straight line here and have the data for either one side of the line or the other. A couple of examples of linearity would be the multi-class logistic regression, a 2-class logistic regression, or looking at the SVM, the support vector machine type of algorithms. Generally, you will have some data sets and some algorithms that work well with that algorithm, but other times it's going to reduce the accuracy there. So you need to make a determination whether this type of relationship linearity is going to be right for your specific data set. They usually quit pretty fast to train them. So it might be one that you look at initially just to try and see how the data performs. So now let's look at the number of parameters. Those are those tunable kind of values that we can adjust to get better performance of the algorithm. Now, over time, you're going to need to run maybe a few different variances of these parameters across that specific algorithm in order to work out which one gave you the best outcome. Now, one way we can do that is with the tune model high parameters module in the machine learning designer. We also call this hyper kind of drive, and it's an automated ML capability. So we can kind of ask it to run for a number of algorithms and a number of parameters for those algorithms, and then kind of evaluate the results at the end. Now, if your training time for the algorithm takes quite a bit of time, this could be something that's significant. You may maybe run this overnight, for example. But you will have a parameter space, which is kind of the different parameter values that you might want to try and test this out with. There's more accuracy if you try a few different variances this, but potentially there's the downside. It's going to take you longer to train and more costs associated with doing that. But ultimately, if your accuracy is going to be one of the things that you really want to get to the highest degree possible, you're probably going to need to try a few variants of this and manually or through an automated process achieve that. So that's what the parameters are about, in tweaking those kind of inputs to that algorithm. So now we move on to the number of features. Now this is essentially, do we have a few features inside of this? Do we have a large number of features? What is the types of data we're processing? Can all make an input into how many kind of different algorithms we're going to run. You know, the types of algorithms, for example, the support vector machines are well suited to data sets with a high number of features in them. But you're going to also, you're doing like text and image classification, then that is going to be a great one for that. So it does depend on the type of algorithm you're trying to run, the type of question you're trying to ask of the data. And we have the filter-based feature selection module that helps us with choosing kind of the algorithm to determine what would be the better algorithm to use there. So we're going to apply some statistical tests to our inputs with a given output, and then we're trying to predict which of those columns, which of those features are going to be more predictive in terms of what the outcome of that module would be. So there's also the permutation feature importance module, which essentially scores the amount of importance a specific feature has in that data set. So we can kind of use these techniques to help with the understanding of which is the better algorithm and what are the different features inside of that data set that are going to be important. Okay, let's now talk about deployment. So we have a goal inside this section, which is to deploy our model to a production-like environment. Maybe that's a QA or UAT, but eventually it could be just the production environment. We're going to want to operationalize the model, and that's essentially putting it into some kind of code that we can kind of then process and take that model file itself and then put that inside of one of the containers or a web service and have that operationalized. Now let's look at deployment. Now here we have a goal where we're going to deploy that model using one of our data pipelines into one of the production or production-like environments. We're going to need to do that to get the user to sign off on the process so that they are happy with the way that the application works, the model's performing, etc. To do that, we need to operationalize the model, and that's going through the steps to deploy that model through maybe Azure pipelines or automated ML, kind of into then a kind of deployment step there. So it depends on how we're going to achieve it, what techniques we're going to use, and what tooling we're going to use. Ultimately, at the end of the day, we're going to want to deploy that into a production environment, have some artifacts, which are some information that tells us about how the system is working, some key metrics, maybe a deployment report that's going to tell us how well that's been deployed, where it's been deployed, what size of the deployment was, what specific version of the algorithms and parameters we're using, all this information, and maybe even a solution architect document that kind of showcases how it fits into the rest of those deployments. To operationalize a model, we need to perform a number of steps here. Now, depends on the model and depends on the business requirements, really what we're talking about. So that's usually kind of giving them an API call through a web service. We can kind of say, here's the web service URI, send us this information, it then sends it back. That could be a real-time inference deployment. We also have a batch version, which we are saying, let's take a bunch of data and process it in a batch. So we have these different inference deployments here. Now, You may have a website that's kind of doing that deployment. So people put some data into the website and submit. It goes off, processes the data, comes back the result, and then renders that back in the web application. We could have it connected to other systems with like spreadsheets or dashboards where the API call is being done and will then render in the result of that. So there's plenty of applications you would have, maybe line of business or back-end applications that would use these API service calls. There's some examples of that where we can kind of deploy an Azure Machine Learning Web Service through the endpoints, and we can kind of go and test those out and see how they're consumed. You're going to want to build some monitoring and telemetry into that process so you can kind of actually see how well that's been called, what the results were. You may want to log this information into some storage accounts so you can come back later on and do some more in-depth analysis on the way that that model was performing. What data was submitted, what was the result, and then did that kind of be accurately reported? Did we get the right result, for example? And the final stage we have in the TDSP is that custom acceptance. So here we're going to figure out what the final deliverables are going to be. That's the pipeline, the model itself, deployment into there. Did it do the end goal? Did we achieve that? Did we have success? What was the accuracy of the model? All these information need to be kind of put together so we can kind of have that handoff to the customer and know that we can move on to the next project. So we're going to have two main tasks, which is the system validation. That is, did it deploy correctly? If so, how often are we deployed it? What version are we at? All this kind of information will be kind of need to be shared. And if we have any handoff documentation to put to maybe the support team or the customer on how to utilize it, it could be a web page, it could be just a document. It depends on how you deploy it and how kind of the users are using that system on how you make that data available to them. But ultimately, you probably need to provide some level of instructions on how to use that system. And now that is kind of the end of the 5 phases that we have in the TDSP. So we've talked a lot right now, probably about an hour's worth of kind of the sessions already gone. And we're now going to move into the Azure Machine Learning Service demos and show you how we get this set up. We'll look at ML Ops. We're going to have some demo now time, mostly in this second half. So first off, we're going to go and have a look at what is the Azure Machine Learning Service and how we provision this service up. So we're going to jump into a demo now and show you all about creating this service in the Azure portal, then connecting to that workspace. Okay, let's get started with the demos. We're going to look at the Azure Machine Learning Workspace first. We're going to show you how we provision that up in the Azure portal, and then how we can navigate through the interface and create assets such as compute, experiments, and a lot more. We're going to get started with first showing you how to create the resource. So if I click on the Create Resource icon in the top left of the Azure portal, it's going to ask me for what type of resource do I want. So in this case, I've got two options. I kind of type in what I want in some of the sections. I'm going to choose machine learning here, and under the marketplace, which I kind of just move my headset a little bit, you'll see that we have the machine learning entry there. So I'm going to click on that. And this is going to open up a blade, which is going to be filled in with the details. So I'm going to choose a specific subscription. I'm going to choose one of the subscriptions I want to use. I'm going to choose a resource group. I'm going to choose an existing resource group that I already have. And here in the workspace name, I get to choose the name of the workspace. So I'm going to do something very simple like Azure Machine Learning Workspace _ Summit 2020. What I'm looking for is a green check mark to the right of that. And I can then choose also which region I want to deploy this in. In this case, I'm going to go to West Europe, click on Review and Create. There's additional tabs. There's Basic, Networking, Advanced Tags, and Review and Create. Under the additional ones, I have options there, which I'm just going to leave those alone for now. I'm going to choose the Review and Create. It's gone green, and click on Create. That's now going to kick off the creation of a new workspace for me. It will have no assets in it once it's built. This will take 1 to 2 minutes for it to completely deploy. Okay, so we're going to wait for that to happen. What we're going to do while we're doing that is we're going to look at existing workspace I have and explore that. So we're going to go into my workspace already created, and we're going to showcase there's a bunch of experiments I've already run in here, a bunch of compute I've configured. Done that up ahead of time because obviously it takes time to create these assets, and we only have a certain amount of time in our demos today to showcase some things. So we're going to show you certain things, but we won't go through everything that we've done. Let's go and have a look at some of the infrastructure here. So under author, we have our notebooks. These are folders where we can kind of place our notebooks and other inserts. We've got things like the samples, and I can go and look at all the details in the samples. For example, how to use Azure ML, how to maybe kind of do management of that, pipelines, you name it. There's a whole bunch of examples there. Let's go back down to the training. I'm going to go to using environments, and we can see that we have examples for the Jupyter notebooks and the YAML files as well. So lots of options there. We'll come and look at some of these a little bit later on in our demos. Under experiments, I've got the existing experiments I've run. I'm going to pick the MLOps Python. So I'm going to show you the Git repository for this and how we walk through the steps of building this, so you can follow along and do those same steps as well. Here I've got a previous run that I did a couple of days ago, and it gets all the steps and the success and how long it took and which compute it used, and a bunch of tags as well. Notice if I look at the tags, there's probably a ton of them, and they're relating to pipelines. And this is going to be something I'm going to show you, which is the MLOps pipelines that we can kind of build. It's a great way of kind of building the experiments manually and running those. But I want an automated process to encapsulate what we're trying to do in this machine learning development. So to do that, I'm going to go and open up. Let's go to the very top and open up the MLOps GitHub repository. Now, this is an example workthrough of a diabetes regression algorithm. And we're going to use the CI/CD operation practices to build our model and deploy that. And we're going to take off through the steps in there. So we're going to use a DevOps environment. We're going to set that up. We're going to create our variables for all the connection information we need. And then we're going to build our pipelines. So we're going to spend some time just walking through that right now and have this all for you. So let's have a look. So I'm going to go into my DevOps environment. Let me kind of just bring up that environment for you. So I've got one I created for this project, for this specific session called Demo Project for Past 2020, MLOps, and it's a clone of the GitHub repository. To do the clone, we will go down into the section where it says Get Code, and we're going to go and grab the repository template. So if I open up in a new tab, here I'm going to create the repository name, and I've already got my DevOps repository sitting there waiting for me. This is what I'm going to clone that into. And I'll just show you an example of a clone. Oops, give it a name. Clone and MLOps. And you see that the name's available because it's in my repository. I need to have a unique name to clone that into. So we'll just put example MLOps. And that's better. And click from template. So I'm going to clone it from the Microsoft MLOps repository and then create my own repository local. And that's now going off and doing that. So you see it's going to walk through. It's going to clone out that environment for me. We'll wait till that completes. It's pretty much done. You can see that it's kind of gives me a breakdown of what's there, gives me the details of what this specific GitHub repository is about, which is the MLOps continuous integration, continuous development, delivery rather, train model, package, validate, deploy, and monitor. So we've got all these steps here, and here's all the kind of other references we're going to need there. So that's good. We're kind of ready to go with that. I'm going to create the first part of this, which is the variable group. So I'm going to go into my project. I'm going to come down into the project itself, click into that, and I can see I've got kind of a high-level README file, everything there. And if I go into my pipelines, I'm going to go to the library, and I need to create this new variable group. So that is the same variable group that they are referencing here. And we need to create all of these variables here. So to show you, that's all been created. I've given it the names, details, everything I need. And I've saved that and also made sure allow access to all pipelines. Important, otherwise we need to kind of do some secrets and it's a bit more complicated. That's fine, that's good. I'm ready to go, and I can clone that if I wanted to later. So that is my library, that's my variables. Coming down now, we're going to create our connections or create our Azure pipelines. To do that first, we're going to create infrastructure as code with the templates. Now, this will require an Azure service connection as well. So we need to go and set up a few things. Where do I do that? Coming back into my DevOps, coming to the bottom of the screen here and to the left, project settings, click on there, and then scroll down till you see service connections. What you're going to do is you're going to create a new service connection called Azure Resource Connection that's going to connect to the resources that I need. So I'm going to see that we created it earlier this week, kind of and then I'm going to make use of that. So to do that, I would do new service connection, choose the resource manager, next, choose the service principal, automated, fill in the subscriptions. It's loading those right now. So I need to be validated into my subscription. So here's my one I would like to do it in. Here's the resource group I want to change. And this is where I put the name in. So Azure Resource. And we go description and save. So that's really all it's doing. It's kind of connecting the credentials for me to connect to my Azure environment and get those resource groups access. So I've got a few there. I kind of do some management on this later on. I could go and remove these ones I don't need. Just kind of just delete a couple of these out. So again, kind of you just make sure you kind of manage this because it can get messy if you don't. I'm just going to remove a few of these. I will get rid of all this when I drop the project anyway, but for now I just wanted to clear this stuff out. So I've got my resource, I've got my service connections defined. I've got my Azure resource connection and my Azure machine learning workspace connection. Ignore the top two right now. We don't really need to be worried about those. Scroll down. I'm going to create my pipeline. And what I'm going to do is I'm going to build those assets. I'm going to build those pipelines. So to do that, I'm going to go into the pipeline. This is maybe built off the forked directory that we just did, the forked repository. So let's go back to the Azure resource, come into the pipelines, and click on new pipeline. So I'm going to move my head position just so you can kind of see the new link. So there's the pipeline there. Click on that. And it's going to say, where's the code? So I'm going to say that's in an Azure repo, which obviously where we are right now. Here's the name of the repo. I'm going to use an existing Azure pipeline. So the YAML file that already kind of defines what the pipeline is going to be. And here it's going to say, well, which branch it is. So we're going to use a master right now, but you could have a strategy you're using other non-master branches, for example, dev branches. I'm going to choose master. I'm going to go then the drop down. I'm going to go and find the file I want, which is the create environment pipeline file towards the bottom here. I'm going to click continue. I want to show you what's in this pipeline. So this is a YAML file, is a definition file, tells me where all the kind of details are. For example, we're now showcasing that we are using that. I'll zoom in a little bit. That variable group that we created earlier. Okay, so you can see that we have information being, let's kind of zoom out again, information about some of the connections are with the dollar symbol in front of it, telling us what the base name is, what the resource group is, so all those variables. So we can have the script and we can just change the variables in the variable group to deploy maybe to production, dev, etc. We just have a different set of those, and then we can kind of decide which one we're going to deploy into. So if I click on run, that's going to do that. I'm going to just click on run to show you kind of how this runs. I've already done this before, obviously, and it's now going to queue up that job. The job will then get queued up and it will be processed through the DevOps containers that are out there that are going to process all those jobs that we have. And eventually then what we have is a pipeline that will succeed or fail. And we're going to explore the details. So let's look at the previous pipeline, why this one's running. So that's currently the one that we're currently running. You can see the blue spinning symbol there. Let's go look at the one we did earlier, which is the model train register CI. And in here, I'm going to drop into the run. And I can see the different steps involved, what it's actually done. If I want to see the details, I can click into that as well. I can go through each of the different phases that this step has done. So I'm not going to go through all the details of this. We just don't have time for that today. But if you want to see the details of what your steps are doing, this is where you get them. You kind of drill in. We've got the model CI and also train the variant model. Each of these steps, again, individually have the different phases of that. So we're evoking maybe the ML pipeline here. Details, it's a JSON file, so it's kind of hard to read there a little bit. And I also had an indicator of, I don't know if you can see it, is I've got an email that actually come through now saying that that build succeeded for me. I won't be able to show you case that. No. So this is the job. I'll go navigate back. I'm using the breadcrumbs to go back to my pipelines. I can see that it can run, that run is done. And we just succeeded, and it didn't take very long at all. If we go into the job, we can see that that's basically the steps it did. But that's not the only thing that we're trying to do here. Let's go look at some more steps there. So that was the first pipeline to build the infrastructure. We built the YAML file, we deployed it, and off that ran. Now we will need also a connection to the Azure machine and workspace. Remember I created that workspace a little bit ago? We're going back and see if that's deployed. It has. I'm going to launch that. I'm going to click on Launch Studio, which is going to allow me to launch that machine learning workspace. In here, I've got no compute. Nothing at all. I've got no notebooks, got no designer experiments being run. It's all empty right now. It's just kind of an empty project, okay? But we can use that environment now, this workspace, to build all those environments up. So let's go back to the workspace. We're going to build up the machine learning workspace service connection to connect to that workspace we just built. Let's go do that. So let's go back to our library. We can see we've got the environment there. We're good to go. We are wanting to go back to project settings, go down to service connections. And this time I'm going to create this workspace connection. Let me just do that. New service connection, resource manager, service principal. This time now we choose the machine learning workspace option, and we're going to connect to the subscription, the resource group, and this is the one that we just created here called AMLS WS Summit 2020. Give it a name. So AMLS Workspace Summit. We'll call it, what was it? Workspace connection. Workspace. Oops, I can't spell. Connection. There we go. So I've got, instead of AMLS, AM dash workspace, I've got AMLS WS workspace, just so it's got a slightly different name, so I can save that. We need to make sure that when we look at the library in terms of the connection, so we kind of go in and just go to the pipeline, go to library, in here. This here is the one that we need to change to, so AMLS workspace, I forgot what it's called actually, 1 second, go back and change that. So, project settings, service connections, it's AMLS WS. Okay, that's correct. Okay, let's go to the library. So I've changed the workspace service connection variable to reflect the workspace I want to do here. Okay, so let's save that. So I don't need to make any changes to the scripts. I just changed the definition of the workspace connection that I named that connected me to that specific workspace. I'm sure that makes sense. Clear a couple of the screens at the bottom. So let's go and look at the next stage, which is running the kind of phase of that. So we want to go and create and run this pipeline here. So we're going to run the diabetes regression CI YAML file. We're going to create a new pipeline that's going to build out this. Let's do that. So we're going to go back to the project, go to pipelines, go to new pipeline. I'm going to go to repo git, choose the repository, grab the YAML file, and this one was the regression CI. Click continue. Now here you can see that this is what it's doing. It's running these specific Python scripts. And if we go down, we've basically got the workspace connection as a parameter in here that we just updated. So that's now going to connect to that workspace and run these scripts here. So we're going to create a trigger pipeline, etc. So let me just go and click on run. So this is going to do the same as what we did in the previous example. It's going to create the model CI, and it's also going to do the training of Azure. So we don't have any these steps completed yet. Right now it's queuing this up. So we'll come back and look at this shortly, but that's kind of what we're trying to do. Now we're building that pipeline. If we go and look at the assets, so I need to find the right one. This one here, go and look in compute. Nothing in here yet. We haven't got to the point where it's going to put this stuff in here, but I think we will soon start seeing stuff come under the pipelines. It's going to take a few moments for it to connect and start spinning up the resources it needs. So we'll come back and look at this shortly. So again, it's still building up that pipeline. We can see it's kind of queuing it up right now. And my head's in the way a little bit of that, so I was going to move my head a little bit out the way. There we go. So you can see that we are queuing right now for that job. When it's ready, it will process that one. So I'll leave my head where it is in the top right corner there. Okay, let's. You can see actually, if you look down, it's kind of it's initializing the job right now, and it's processing through, and we can just kind of watch that for a few seconds and see the processing of the various sections here. We'd probably give it a few minutes and come back and look at the completed state of that. But you know, this is, if you want to watch it, you have the ability to do so. So that's going to be great. We can come back and look at that. If we go back to the pipelines in the machine learning, we should start seeing these come up at some point, and there should be clusters being built and reviewed here somewhere. So we're going to leave this kind of in the background. We'll come back and look at the data. While it's doing that, let me show you the tutorials available inside the machine and workspace. So if you want to learn about notebooks or creating some new examples, understanding automated ML, some of these different services, while we're waiting for those services to spin up, I'm going to take you through the automated ML environment. We don't have anything right now. We're going to also need to create some compute as well. So let's do that while we do the automated ML. I'm going to create a brand new data set. I'm going to use the open data sets from the Microsoft World. I'm going to go and grab, let's say, the diabetes one. Here. Click next. Choose the name. So we're going to use diabetes data set. It's version it as version 1. I'm going to choose that data set. I'm going to click next. This is where we get to then choose what the experiment's going to be called. So I'm going to create a new one called experiment diabetes. Diabetes. And we want a target column. So in this case, I want to go to the Y column because I want a yes or no. Is it predicted to be diabetic or not? What's the outcome? Compute, I don't think anything listed here yet. So I'm going to create a new compute. So I'm going to choose a dedicated CPU, and I'm going to do, let's say, a DS3. And I've got 48 cores. I'm going to use 4, so that's fine. I'm going to click next. Compute name, I'm going to choose this as, let's say, DS3 V2 dash compute. And this is going to be in the same location as where I define my machine learning workspace. In this case, I think West Europe or East US. I'm going to choose the maximum number of nodes. This is going to be a maximum of 4 nodes and a minimum of 1. Now, the reason why I've gone with 1 is because I want this to be up and running all the time. But I could put 0, and I could actually have it completely go quiet. Just means that kind of there's a bit more spin up time. But for demos today, I'm going to get rid of this later. I'm going to choose minimum 1. So once it's up, and I have that connectivity there. I'm going to click create. This will take, again, a few moments to build because we're actually creating a VM with the configuration settings. So we'll come back to that one. Once that's finished building, I can go to the final stage of this automated ML, which is choosing which algorithm I'm going to use. So regression, clustering, or time series. We'll show you what that looks like in a moment. So I'm going to leave that screen where it is. I'm going to go back and look at the pipelines and see how they're getting on. Okay, so it looks like there was an issue which is unusual. Normally, this has come through successfully. Let me go back and have a quick look. Okay, so let's rerun that failed job and see if that succeeds. If not, I've got one which I did. So all the runs I've done previously, examples of just kind of managing, testing this out, have succeeded fine. But there are occasional errors, and demo gods sometimes shine on us favorably and sometimes not. So looks like we're waiting for the stages. It's kind of doing that. It's queued up right now. It's going to run through that once again. Once it's done that, we will see if it's kind of see the previous step it tried to do. This is attempt 2. We can see attempt 1. So we can see kind of how it's progressing through what its previous attempts were, how well it got. So if you might need to fix something, generally sometimes if the compute's not quite up, it kind of fails sometimes, some of the steps, and you have to kind of kick it off again. But normally it's kind of pretty good. I don't think, so it looks like we're ready to go with this compute now. I click next. I'm going to choose either classification. Now in this case, this is the one I want because I want a yes, no. I want that label to say diabetic, non-diabetic, 0, 1 essentially. Okay, so I'm going to choose that, but I should have regression or time series if that was the appropriate type of learning task. Click finish. This is now going to start the automated ML experiment for me. And what it's going to do is going to pick a number of the, in this case, classification algorithms, and it's going to try them out with the same data set each time. We're going to then see which is the winner in terms of accuracy, which is the best model. And we can then deploy that best model. We're going to showcase that a little later. So that's running. Let's go back and see if we have some success with our pipelines. If not, we're going to look at a previous run. So this is currently running. These are the tests that it's kind of run. It's run 37 tests. We can go in and see more details about that if we really wanted to. Right now, we're not going to take that time. But this is the pipeline running. This is the previous pipeline I ran, which is exactly the same pipeline. So you see that we have all those steps, and they completed successfully in a few minutes. And then once it completed this stage, it went on to the train and evaluate model stage. And then there will be other stages. Those stages are detailed in the instructions here. So you can see that we have that. Once we've done that, we're going to rename the model, the pipeline rather, to model train register. And we're basically going to then do another one, which is the regression CD. So we did the CI, continuous integration, and now we've got the CD for that deployment. So we've got another model that we're going to run off that will take that. We won't run this one. I've already done this one. I'm going to show you the one I've already done just to save time a little bit. But this is the stages you'll go through. You can go and check out all of the details of each of the stages and how well it performed. We're also going to do a regression batch scoring one as well. So a new pipeline for that. And it will have the build batch and the run batch scoring pipeline. So we're going to run those two. And then we'll be able to kind of see what these individually are doing. We may want to deploy into an Azure container instance and potentially even into an Azure Kubernetes service, AKS. Let's go look at what we had from our previous runs. And we can see here, let me go to my complete pipelines and go to my batch scoring. So it looks like that one succeeded in the previous runs I did. And under these pipelines for our MLOps 2, we also had all those steps kind of completed successfully. Looks like the one I'm running right now is failing for a reason. I'm not going to have time to troubleshoot. So it looks like there is a problem. We can see it's the publish pipeline. So it could be it's not, so it's no workspace found. So it looks like I maybe have named the workspace incorrectly. Let me just have a quick look. That's not unusual. So it's AMLSWS underscore summit 2020. Let's see if I just made an error in my property settings for my, oh, wrong one. I need to go to my library in here. So actually, the resource connection is called workspace name is the wrong way. So actually the workspace name is what I needed to change as well. And that is AMLSWS underscore summit 2020. The workspace connection, I think we had, let me just save that and go back and look. So I think that's where I made the mistake there as well. I'm going to go into the service connections, and the service connection was AMLS workspace connection. That is correct. But I went to my library, I also had to make a change to that setting. So let me go into my library. Sorry, not getting where I need to. Click on there. Okay, why is that not coming out? Oh, it's too refreshing. So we kind of just exit out that. Coming into my library in here, and this is Summit 2020. So I'm going to rerun that. That is the name of this workspace. Okay, so let me go rerun that again. These are the things sometimes you just make mistakes on, and so that's a good thing. I'm going to go to the pipeline. I'm going to go to my failed pipeline. I'm going to click into it. I want to go and rerun all jobs. I rerun all jobs on this one. I just want to get that to run everything again. So this was trying to connect to a workspace that was a different name that didn't make sense for the connection I had. Let's see if we get successful on this one. Okay, let's see why we're waiting for that. If we have the other entry, so go back to this run here, refresh. This is currently running. This is our machine learning automated ML. So it's actually in the process of spinning those up. Looks like some weird looking numbers there. I don't know why. You get that sometimes a little bit. I've seen that a few times. But this is the one that we started just a few minutes ago. And we'll wait for this to go. This is the diabetes experiment, classification, accuracy, running. So we'll give it, I don't think the data guards are up. There's one actually that is alerted. So this helps with that data analysis, understanding is the data, maybe kind of got just an imbalanced data set. This is kind of giving us some understanding of some automatic featureization that the automated ML comes with to kind of tell us that the data is of high quality or not. If it passes everything, we should be good. If we get alerted, we may need to investigate the data. I'm gonna ignore that for now, but we'll carry on doing the models. And it's actually started the first one already. So we've got this one running. We won't do all the details right now, but you can see the accuracies metric, but there's a ton of other metrics you can see already kind of available. That is from the built-in technology to score them across these different metrics. So we can kind of choose which one is going to be the primary metric we want to use. In this case, we're probably going to use accuracy as the primary metric. So once we've done that and we let that run go through, we will probably have multiple models we can actually see, and it will then start putting the winner above. It will kind of score it in descending order of accuracy. So number 7 was the most accurate. Some of the others look like they're queued or running currently. Okay. Let's go to our pipelines and see if we have success on this. Looks like probably might be successful this time. Fingers crossed for demo girls and Neil not to make a mistake in the demo itself, which is, it happens, especially when I code and type. So let's go back and look at the overall steps. We kind of have that deployment, we're waiting for this phase to come through. Then we're going into this phase. We don't have these other ones yet, but they will be if we go and add in the additional pipelines for those. There's more steps, there's more details, and more kind of login you might want to do about how it's being processed. There's a ton more of information, and we're not going to cover today. If you want to create a local environment, you can do that. Let's go to the link for that. So that will help you set up how to build that local environment if you want to do something locally. And we're going to go and look at a tool called the Data Science VM. There's a bunch of tools as well that we're going to give you a couple of glimpses at today. That's the Azure Data Studio and also the Azure Storage Explorer. But we don't have time to go through all of those, but I will look at the Data Science VM as a demo. I'm going to go and provision it up now because it takes a few minutes to connect and create it. So go back to my resource group. I'm going to go into the resource group. I have my choice here. I'm going to create a new resource here. Now, let me see if I already have one. I may already have a virtual machine, which I do, called Data Science VM Neil. So I've created this already. That's fine. I'm just going to show you the steps to go and create this, but I'm going to connect to this one because it's already kind of up and running. So let's go and connect to create resource, data science virtual. And if I look down, I've got two options. I've got Ubuntu for Linux flavor and Windows. I'm going to choose the Windows one. I'm going to do the set presets, or start with preset here. Choose the dev test and choose general purpose for this purpose and click continue to create VM. And it's going to ask me for the name of the VM, some options about where the region's going to be, other settings. I'm just going to leave everything the defaults there. I will put a username and password in, and then we'll review and create, and then we'll create it. And that will end up being a data science VM that we have. So if I go into my virtual machines, I will see that I do have a data science VM already there. This is currently started, so it's running. And let me kind of minimize some of these screens here. I'm going to click on the connect button here. Give me my RDP file. That will download, and I'll be able to connect. So I've already kind of got that in play. I've already downloaded it, and I'm going to go grab the download file and just drag that over because I want to connect to that one. So I'm just going to I need to double click it, not drag it. Double click. Now I can drag it. I'm going to click connect. I've got more credentials to put in, so I'm just going to go with the more choices, different account, admin Neil. I think that's the one I already did, but I'll put the password in so I can connect. Drag it from the other screen and click yes. Now that's going to now connect to my data science VM. I'm going to kind of leave that there for a little bit, just for it to warm up. And I'm going to also, let me kind of actually full screen that for a second. Let me just check my screen real estate. That's good. I'm in a good place. So I'm going to sign it into Azure. So it looks like I was having some issues with some password resets earlier. So let me kind of just clear those out and see if I can sign in. I'm going to try and sign in with my account. But what I want to do is I'll show there's a bunch of extensions in here. And the ones I've installed so far are the Azure, main Azure ones. So I've got machine learning itself, pipelines, storage, account. So I've installed those. I just kind of typed Azure into the search window and got a list of all of the Azure, kind of Microsoft Azure ones. And I've gone and installed, say, a few of these examples. This will help me kind of connect to those services. I've created a folder. I have access to SQL Server, so I can connect to specific versions of SQL. I've got access to my Azure environment. I'm just going to wait for that to load. So I'm waiting for the bottom right, bottom of the screen as well, just to see if there's any prompts that come up. And sometimes I get prompted out like I need to update or connect into a service, for example. I'm just going to clear these down. Okay, for some reason, I had this earlier. I can't connect into the Azure environment right now. I was wait. Oh, here it goes. It's finally got me the prompt. That's good. So I'm going to see if I can log in. Now, I had a password rechange earlier because there's something going on with the account. So let me just try that again. We'll give it one attempt to see if it kind of gets in. If it doesn't, I'm not going to worry too much about it. I will show you a different demo. So let me kind of try and log in. I'm not expecting this to connect. Okay, so looks like I've got a reset that I need to do, and I won't do that on the screen here. It's going to be too clumsy. I'm going to just go and check I don't have a reset option there. Bear with me, so I'm just going to look at if anything's come through for a reset. Okay, let me try and reset now, just so I can connect in. So I'm going to just check the email account name is correct, and let's try and do that. Because I do want to show you this, and hopefully we'll be able to kind of get that through. So click next. I'm going to text my phone, and let's put the numbers in. And going to wait for that message to come through, and then we'll see if that is. So I've got the message number, so let me put that in. And I'm also going to email, yeah, so let me just email that through as well. Actually, I'll get approval on my notification app. That's probably a better one for me. Just going to validate that. Let's wait for that to come through. There we go. And I was going to put a new password in, so I was going to see if I can kind of connect into this. Okay, let me log in with that username and account again and see if that's successful, because I want to show you we can access the resources inside of the. Oops, I can't type at all today. They say never type in demos. For me, it's never type full stop. Okay, let's try that new password. I do just by habit trying to type the old password in. Okay, looks like we can close that out. Now that's awesome. Now what I have is all of my subscriptions. I'm going to filter this to just the one I want to have. So it just kind of makes it a bit clearer for everything. Let me kind of just filter. And then I want to go in and I'm going to connect to the, kind of grab a couple of these here. So we have machine learning already. Yep, okay. So if I go in and under storage, come into the machine learning space, here is all the workspaces that I have available. I'm going to open up the very top one, which is the one I've just kind of done. And here we've got our experiments, and that they're currently running and queuing, and we can see the operations of those. We can see what models, if they were any models. We're going to look at the compute clusters, and you can see that we have our train cluster and our compute cluster we created locally. So all good, and I can kind of interact with these. I can also go and look at the details of that run, for example, and see lots of, I mean, it's in a JSON file format, but I can go and see details about, you know, what was happening and information about that if I wanted to show that information. So we clear that for a second. Go to the View Experiment Studio, and that's now going to watch this. Click open up my machine learning. Now, this is the one annoying thing about Data Science VM that I always forget. Here we are. It doesn't support the new Edge. So what I'm going to do is I'm going to take that browser URL. I'm going to open up my own browser. can't remember which way I do this, whether I open it up with IE or I open it up with something like this. So I'm just waiting for that to now try and connect. It's going to sign me in. It's going to need to validate who I am, I think, as well. This is kind of why it had a problem. So let me just kind of do that. And let me put that password in. So I clicked on that link. Now it should have automatically opened up the browser for me if I'd been validated in my cache, in my, but this is that experiment that we're currently running. And you can see it's running, and we can see kind of how many models have been processed so far. The accuracy is really, really bad. Don't worry about that. I just wanted to show that we had lots of different algorithms. And basically, it's going to find the most recent up-to-date accuracy level. And once it's done that, it's going to get a winner from that. Now, we wouldn't choose any of these because of the percentages, but it's currently, you know, this is what it's running right now. So we can also access that from the browsers in there. So if I kind of do that again, view in Studio. Still get the message. Don't know why it does that. I'm going to report that problem, but if I go to the browser and manually authenticate, it runs fine through, no problem. Okay. So you see these are running. This is great. We have a ton of different extensions available to us. Won't go through all of those right now, but we can connect to a number of those. Really useful to be able to kind of see what's happening with your experiments inside of your machine learning kind of space with the Visual Studio Code. Let's minimize that down for a second. Go back to our pipeline, and we've been successful on that. We're now running through the second phase. Got a couple of minutes left maybe on that one. That's all we need to kind of do. I'm just going to check the progress of some of it. There we go. That's fine. Cool. So what we were trying to do, we've got Data Science VM up and running, Visual Studio Code, excuse me, Data Science VM, Visual Studio Code, connected to the Azure Machining Workspace, and seeing an existing experiment that's currently running through that. We've got the DevOps for machine and ops being available for us to navigate through. And we can go and see how we build up all of those pipelines and integrate those and have a way of coding our environments and putting our Python scripts and everything else into, you know, source control and version of data. Lots of ways of just kind of putting a process around the machine learning code of our operations, our experiments. Let's go look inside the machine learning workspace a little bit further. And we're going to look at the designer. Now, designer is a code-free kind of environment. It's a workflow. So we're going to pick an example. We're going to choose the regression automobile price prediction. Click on that sample. It's going to load up now in the screen, that template. Now, there's a couple of things. We will need to go and choose which is the compute target. So I click on that. And it's going to say, oh, do the train cluster, thank you. Because that's already up and running, 1 of 4. I know that's running, so that's going to be quicker to get running. And then submit. Now, I could go in and change some of the properties. I need to go and work out exactly what I'm going to be using here. So we can kind of do the connections. There's my data. I could go and review the data if I wanted to see the data first, see what kind of information I have about the data. I've got some statistics. I can see how many rows, columns, very small data set. I can see that we're cleaning missing data if it's needed. Are we removing values, remove the row, for example, or we can replace with a substitute. You know, if it's a 0, maybe put the default value or a normalized value of some type, medium, mode, etc. But we're going to just run that. And we're going to choose experiment. We're going to choose a new experiment here. So we're going to call it experiment. And this is auto submit. Okay, so watch this for a second. It's going to change the screen real estate a little bit. It's going to show here we got all changes not started, and then it's going to kind of go to a queued stage, and then we'll go to kind of processing, and each one it does when it finishes it will mark that with a green indicator on the left hand side. So let's wait for this to kind of change a little bit more as well. We'll be able to see that. So here we've got the queued for a couple of operations. We'll come back and look at the results of that later. But if we want to do a own manual one, we've got the ability to go through and use some sample data sets, build the data sets we've already defined, manually input data or input it manually. Do transformations, add rows, remove duplicates, normalize the data. So all of these, if you kind of hover over them, you get then a link into the document that tells you about what that specific module is about in each of them. So, data transformation, feature selection, statistics, here's all your machine learning algorithms broken down into the regression, clustering, and classification. Notice that's not all of the available algorithms. So the designer doesn't have access to all of them, it's just the most common ones. But if you want to do something like a 2-class decision forest, click on it. And it's going to explain a lot about the parameters and information, and you'll understand that a lot better if you just kind of want to know the documentation about it. Come in, click into the authoring, hover over the one you want, go to the help document, and then you'll get right into the details about that. It's a really easy way of kind of accessing that help file. Okay, so we jump forward a little bit. Okay, so we jump forward a little bit to just see the progress of all of those as we are getting towards the end of the session. I've kind of paused a little bit and waited for those to complete, and then we come back. So here we see the NCY taxi regression model. If I scroll down, you can see that it's processed through all those settings. And let's go down a bit further and show you some of the output of this. So I'm scrolling quite a bit, but I want to get down to this part here where we kind of actually see the kind of data, and we can see how it's been processed, the amount of time it took, some of the steps it took to complete, how long, and different pages of data then it might be processing through, and if it's completed or not. So it might be still doing some additional work there, but we wanted to showcase that that was the kind of result of the output there. We've got some steps that have not finished, and I'll have to go and check why that is, but it looks like we've got the data set that's cleansed. Our data frames have been populated and loaded, and we were trying to look at a profile. I don't think we have the profile built for that one. And we have some final steps that didn't complete because it errored. This is one of the things that you will find, and it's nice to see that it happened actually somewhat, is if you get to a stage and it's errors, it will just stop. So you're not going to get maybe a bunch of errors after that because it's kind of trying to do steps that can't complete. This is going to stop. I need to go back and figure out what that is and fix that one. And that's a nice thing. I could actually then send you this file, and it has all the output for this Jupyter notebook. So we're going to close that one down. We're kind of done for that demo today. We're going to look at the pipelines. It looks like we're nearly done, but I don't think it's going to have time to finish. But that would have been identical to the other pipeline we did before, where we did all the steps. So just waiting for that to follow through and do all the steps there. So this is the pipelines that we ran. We were happily kind of running through all of those pipelines, giving us our results and getting the outcome. So I'm going to close that one out as well, the DevOps, and we'll go back into the final data science VM. This is the virtual machine. We don't need that anymore. We'll go back to our dashboard, and here we can see more information about different machine learning spaces or SQL databases, or where the location of our data sets are in virtual machines, etc. We use our dashboards inside of Azure portal to connect to those resources really quickly. Finally, I'm just going to kind of say this is where the machine learning documentation is. So spend some time having a look through, but you've got lots of links from the machine learning workspace to bring into there as well. So that's a useful thing to know. I would document this somewhere and then come in and understand what is MLOps. And this is where I came out and found out about MLOps when I first started working with it. And it's got lots of good links in here. There's a ton of stuff we haven't covered in a lot of detail. We haven't gone through the Azure Data Studio and Azure Storage Explorer. I'm going to bring up the slide decks very quickly and just end out the session, and then we'll go into Q&A. If you have questions you haven't put in the chat window already, do that right now, and we can tackle those when we get to that Q&A section. Let me go back to the PowerPoint slides for a second, and just bring up the additional slides there. These are more reference slides than anything else. That's going to, again, also make sure that I can see my screen. Let me just put myself in the right position. I should be in the top right corner there. Okay, so Data Science VM, again, just summarize, it's an image in a VM. You size up that yourself. You can put it on Ubuntu or Windows Server, and it's a great tool place to do what you need to do there. Let's look at what else we have finally before we kind of wrap up today. Here's some additional tools. So Azure Storage Explorer. This is a great way of connecting to those storage accounts, Azure Data Lake Store, any data you might want to put into different storage accounts there. You can also connect to things like Cosmos DB as well. Also, you have the Azure Data Studio, one of my favorite tools of use, and this is great for connecting to your big clusters and your different databases. So it has some functional capabilities that are really, really useful, as well as some visualization tooling as well, which we'll showcase in a little bit there. Visual Studio Code is my go-to. You see here is like, I want to do that for ML and AI. I'm going to use Python, and I want it on Windows, and it comes back and says, well, you need to use Visual Studio Code. So this is why I use Visual Studio Code, because it's recommended. And there's also some data science tutorials links there as well. So it's useful for you to kind of download that tool. Python code. I teach in Python and I use it, but we kind of use Python in a bunch of places like our data science VMs, Jupyter Hub and Jupyter itself, Anaconda, Databricks, Azure ML notebooks, you name it. There's a bunch of others as well, like PyCharm, etc. You will be able to use your Jupyter code in a lot of places. I do prefer the Jupyter Hub for training purposes to get people up and running with it, because it's got a lot of additional links and resources that are useful for that training and learning about the subject. We covered our demo for MLOps, so we had that process through, and this was a summary of building that pipeline for the ML and AI projects using DevOps to build that pipeline out, and then just using our services to kind of push those new changes, those new models out. There's a ton of stuff that we haven't gone through in the details, but you get hopefully the overall principle of we're using the Azure Machine Learning Service to build all the assets that we need, and then we're using pipelines to deploy those assets. And here's a couple of screenshots that kind of demonstrate the process flow. Build pipeline, there may be a retraining pipeline operation, you've got a release pipeline, and then you'll put your stuff in production environments. And that was the example of the variable group there. So for me, this is a big thank you for joining this session. Hopefully you found it interesting, informative, maybe thought-provoking. Look into this world of data science and AI projects. Now, we focus mainly on data science today and the machine learning, but AI is more about kind of that, running those cognitive services, pre-built machine learning algorithms, all building your own. And so I've kind of gone with the overall principle, kind of the process is the same. If I'm doing a machine learning algorithm, I may be calling a cognitive services API as I do the work I need to do. And there's some examples out there for that as well. So that is going to close out the main video production section. We're going to move on to now the Q&A portion. So there's 15 minutes where you can throw questions at me, and hopefully be able to give you a nice answer to that. And we will be sharing links and resources in that section as well. So if you want some links to some of the materials you've seen today, stay around. I'll be putting a bunch of links up for you as well. But for now, that's a goodbye from me. I enjoyed the journey, and hopefully you did as well. And I'll see you in another summit session, maybe down the road. Enjoy the rest of your summit. Reminder, do the evaluation, please. Okay, folks, bye for now. See you soon.